So here's my predicted paper for paper 3 on the 14th of June. We've already had paper 1 and 2 now, so I've been able to knock a lot of topics out. Here's what I think is really likely to come up. You've got a list of all of the topics here that I'm going to include in this video. Hopefully I get through it. My voice is struggling a little bit, so yeah, wish me luck. Hopefully I'll make it to the end. So question number 1, A is simplify n cubed times n to the power of 5. Now n cubed is n times n times n, and we're timesing that by n to the power of 5, which is n times n times n times n times n. So we know that altogether that's going to be n to the power of 8. When we multiply, we add the powers. For part B, we're dividing. So when we divide, we take away the powers. If I've got c cubed divided by c squared, I'm just doing 3 take away 2, which is c to the power of 1, but we don't bother writing the power of 1, we'll just keep it like that. And then d to the power of 4 divided by d. Now remember that d is the same as to the power of 1, and 4 take away 1 is 3. So that's going to be d to the power of 3 for 2 marks. Question number 2. Last year, Jo paid £245 for her car insurance. This year, she has to pay £883 for her car insurance. Work out the percentage increase of the cost of her car insurance. So percentage increase or percentage decrease or profit is change over original times by 100. So the change is just how much it's changed by. The original is what it was first. In this case, that's 245. And then we're just going to times it by 100 to get it as a percentage. So the change is 883 minus 245. And it's out of the original, which is 245, times by 100. So percentage increase, percentage decrease, or profit, you're going to do the same formula, and it is that change, 883 minus 245 over 245, times by 100. So change over original times by 100, and that is 260.4%. So it's a 260.4% profit. Now that makes sense, because if it was an 100% increase, it would have gone from 245 and it would have doubled and been 490. So that would have been an 100% increase. And actually, if we add on another 245, that would have been another 100% increase. So that's not a crazy answer. It seems a little bit crazy, but it's okay. Question number 3. Complete the table of values for y equals x squared, add x minus 4. Now, if this was a non-calculator paper, I would be telling you to do this very differently. But given that this is a calculator paper, paper 3, I'm going to say do it one of 2 ways. The first way is to use brackets. So in your calculator, you are going to type this. But every time you see an x, you're going to use brackets. So bracket, bracket squared, add bracket, bracket, minus 4. So we're just rewriting this, but with brackets every time there's an x. Now all you need to do now is go back to those brackets and put minus 3 in both of them. Get your answer and then click the left arrow, go back to both of those brackets and change it to be a 0 in both of the brackets. And then left with your arrow on your calculator, go back, change them both to be 2s. And then go back and change them both to be 3s. And that will give you the answer for each. The other way to do it is to use the table function on your calculator. So if you click menu, and then it's 3 on mine, it might be slightly different on yours, but it will say table, f of x comes up. Now you're going to type x squared, add x minus 4. On my calculator, to get x, it's alpha, and then the right-hand bracket. So x squared, add, and then I'm going to do that alpha bracket again to get another x, take away 4. Hit equals. Mine says g of x, yours might not. Your calculator might just say f of x, that's fine. Hit equals again if it does, because I'm not interested in that. And it'll ask you for the start. Now the start is wherever your table is starting. In this case, minus 3. Hit equals. And then you need to say where it's ending, which in this case is 3. Hit equals. And then it'll ask you for the step. Now the step is just saying what is it going up in, and we're going up in 1s, and it will probably be 1, so let's just hit equals again, and now it will give you the whole table, and we can see that minus 3 requires a 2, minus 2 is a minus 2, that's fine, we've got those already. Going down, scroll down using your down arrow, 0 is minus 4, 1 is minus 2, 2 is 2, and 3 is 8. So either way, whichever way you're more comfortable with. Now I will just say, once you're done with the table, to get rid of it, just press menu and go back to 1. menu 1 to get back to where you started. If you forget how to get back, just press Shift 9 3 equals AC. That will always reset your calculator and take you back to the main screen. There we go. Now each of those is a coordinate. So we're now just going to plot those coordinates. -3, 2. Right, now before I start plotting, let's look at this very carefully. I've got 10 squares making 5. So this is 1, 2, 3, 4, 5. So it's 2 squares that make 1. So just be really careful when you're plotting anything on a graph. So we're -3, 2, which means we're going to here. -2, -2, which will be 4 squares down, so that's there. -1, -4 is going to be there. 0 -4 is there. 1 -2 is there. And 2, 2 and 3, 8. You're just going to join that up with a nice smooth curve. Oh, if I can. Don't like that. Just a little bit, there you go. So make sure that when you're drawing a quadratic, if you've got 2 values at the bottom, that you want to dip slightly below them like that. Okay, nice, should be a nice smooth curve, but you shouldn't have a flat bottom like that. Should dip slightly below and come back up. There we go, so that's a quadratic drawn on the graph. And it then says, use your graph to estimate a solution to when that quadratic equals 0. So they're essentially asking us for the roots. They're saying, when does it equal 0, which is when it crosses the x-axis. If they asked you when it equaled 5, you'd need to draw a line going across at 5. If they asked you when it equaled -2, you'd draw a line going across at -2 and just look at where it crossed that line. But here they've just said, when does it equal 0? So we're looking at this coordinate here and this coordinate here. So my answers for this are going to be -2.7 and 1.5. Those are the 2 places where my quadratic equals 0. Question number 4. The table gives information about the times taken in seconds by 18 students to run a race. Work out an estimate for the mean time. Give your answer correct to 3 significant figures. So the mean from a frequency table, we know that one student here ran the race between 5 and 10 seconds, but we've got no idea if it took her or him 6 seconds or 10 seconds. We just don't know. But we're always going to have a sensible guess and go in the middle of the category. So let's just say 7.5. For the next students, we're going to say 12.5, then we're going to say 17.5, and then we're going to say 22.5. So that's in the middle of each of the categories. We then say one of those, 2 students each going 12.5 seconds, 7 students each doing 17.5, and 8 students doing 22.5. We times across, we add all of that together. So one lot of 7.5 is just 7.5, 12.5 times 2 is 25, 17.5 times 7 is 122.5, and 22.5 times 8 is 180. Adding all of that together, 122.5, add 25, add 7.5 is 335. Now, the most common mistake I see then, if they asked you the total, that would be your answer. But the most common mistake I see now when you're asked for the mean is people end up dividing by 4 because there's 4 categories. But there weren't 4 students. We were told in the question, and we could also work it out here by adding this column up, that there were 18 students. So 335 divided by 18 is going to get us our answer for the mean. And they want that answer to 3 significant figures. My calculator gives me 18.61 recurring. So to 3 significant figures, it's going to be 18.6. Just going to pop that down here on the answer line, 18.6 for 3 marks. Question number 5. Write 37 centimetres cubed in millimetres cubed. 1 centimetre is equal to 10 millimetres. So normally, if I'm going from centimetres to millimetres, I would times by 10. But I'm not going from centimetres to millimetres, I'm doing centimetres cubed to millimetres cubed. In which case, I need to times by 10 cubed, which means times by 10, times by 10, times by 10. So it's not going to be 37, we need to times by 10, times by 10, times by 10. So the answer is 37,000. Question number 6. Nima was driving to a hotel. He He looked at his sat-nav at 1:30 and it said the time is 1:30, the distance to your destination is 65 miles. Nima arrived at the hotel at 2:48. Work out the average speed of the car from 1:30 to 2:48. So first we need to work out how long that's been. Let's draw our triangle as well. Speed, distance, time. So to be able to work out the speed, we need to do distance divided by time. We know that the distance is 65 miles, but we don't know the time. So the time is from 1:30 or 13:30 to 2:48. Now that is 1 hour would get us to 2:30 and then another 18 minutes. That's how I work it out in my head anyway. 1 hour and 18 minutes. So I've got to now type that in my calculator. Now, a lot of you would like to change that and make it 78 minutes, and then you'd have to put it back into hours at the end. I really like for this method, because I want to do distance divided by time, I want to do 65 divided by an hour and 18. Now, you can't type 1.18 in your calculator. That is not an hour and 18. But you can use the mixed fraction number. So you can put 1 hour and 18 out of 60. Now, if you're going to type that in, you have to use the mixed number fraction. You can't just type it in next to a number and a fraction. So you need to press Shift and the fraction button, and that will enable you to type that in as it is. So 65 divided by, and then press Shift fraction, and that is 1 and 18 out of 60. And that gets you straight away to the answer of 50 miles an hour. Of course, you can do 65 divided by 78, because it's 78 minutes. And 65 divided by 78 is 0.83 recurring. But then because that was in miles per minute, you then just need to times it by 60 to get it back into miles per hour, and that would be 50. So nothing wrong with doing it that way whatsoever. I just think this is slightly quicker, but either way it's going to get you the correct answer, so do whichever way you feel comfortable with. Question number 7, and we've got standard form. Write 1.63 times 10 to the power of minus 3 as an ordinary number. So timesing by 10 to the power of minus 3 is the same as dividing by 10, dividing by 10, dividing by 10. So 1.63, if we divide that by 10, we're going to get 0.163. Divide it by 10 again, we're going to get 0.0163. So this is going to end up being 0.00163. For part B, to write this number in standard form, it needs to be a number between 1 and 10 times 10 to the power of something. So this is going to be 4.38. Now, obviously it's the numbers that are moving, not the decimal point, but it's way easier for us to move the decimal point. So let's just say the decimal point is here at the minute, and we want it to be here. So that is 1, 2, 3, 4, 5 jumps. So it's 4.38 times 10 to the power of 5. Also good to remember that a million is times 10 to the power of 6. So if it's in the 100,000s, that's going to be times 10 to the power of 5. And then for part C, work out 4 times 10 to the power of 3 times 6 times 10 to the power of minus 5. Now you have a calculator. This question I think was taken from a non-calculator paper, but you've got a calculator, so you might as well just use it. And I would type it in exactly as you see it there. And that gives me 0.24 in my calculator, but I do now need to put that back into standard form. So that's going to be 2.4 times 10 to the power of minus 1. Question number 8. The diagram shows a regular pentagon and a parallelogram. Work out the size of the angle marked X. You must show all your working. So when we have a triangle, we know that the angles in a triangle add up to 180 degrees. For a quadrilateral or four-sided shape, we know it adds up to 360 degrees. And every time you add a side, you add another 180 degrees. So a pentagon is 540. A hexagon would be 720. Now the formula is the number of sides take away 2 times by 180, but I just know 180 bigger than 360 is 540, so for this question I'm happy to just say a pentagon, a 5-sided shape, adds up to 540 degrees. And because it's regular, we know that all of the angles inside the pentagon are the same. So I'm going to do 540 divided by 5 to find out how big each of these angles are around the outside, including this one here. So 540 divided by 5. How many 5s go into 5? That fits in once. How many 5s go into 4? It fits in 0 times remainder 4. And how many 5s go into 40? That is 8. So I've got 108 degrees on each of these angles, including this one for both of them. Okay, so that's step 1. Now for step 2, we've got here a parallelogram. Inside a parallelogram, because you've got co-interior angles, you've got 117 degrees here, but you know that these two would add together to make 180. So 180 take away 117 is 63. So I then know that this angle here is 63 degrees. Out of interest, this one would also be 117 and this one would also be 63, but we don't need those two. So now we can just work out that the angle marked X here is just 108 take away 63. So 108 take away 63. 8 take 3 is 5, and 10 take 6 is 4. So we're left with 45 degrees, and that's our answer for angle X. Question number 9. The box plot shows information about the length of time in minutes some people waited to see a doctor at a hospital on Monday. Work out the interquartile range of the information in the box plot. Don't know why that S is there. Sorry, that's a typo. Work out the interquartile range of the information in the box plot. So the interquartile range is the difference between your upper quartile, which is the top of the box, and the lower quartile, which is the bottom of the box. In the middle, we've got the median. And then this value out here is the highest value. And at the bottom, we've got the lowest value. So the interquartile range is your upper quartile, take away your lower quartile. Right, this is going to take some closer inspection. So we can see that it's 10 squares to go up 40. From 160 to 200, it's 10 squares and it's gone up 40. That means each square must be 4. So 1, 2, 3, 4, 5, 6, 7 is 28 above 160. So that's 188 for the upper quartile. Subtract, and then down here we know it's going to be 4, 8, and then halfway makes it 10 above 40, so that's going to be 50. 188 minus 50 is 138 for our interquartile range. Becky then says 50% of the people waited for at least 2 hours. Is Becky correct? Explain why. Now the way that the quartiles work in a box plot, you know that below the median 50% of the people are here. And you know that above the median, 50% of the people are here. The lower quartile is positioned a quarter of the way through the data. So 25% of the people are between here and here. 25% of the people are between the lower quartile and the median. We've got 25% of the people between the median and the upper quartile, and 25% of the people all really squished in here between the upper quartile and the highest value. So if she's saying 50% of the people waited for at least 2 hours, we can see that actually I agree with her. 2 hours is here, 120. So 50% of the people would be above the median and 50% of the people are below the median. So therefore, yes, Becky is correct. So 120 minutes is the median. So 50% of the people waited longer than this time. So it's because the median's at 120 that we can tell that. And then for the next section, the table gives information about the length of time in minutes some people waited to see a doctor at the same hospital on Tuesday. So this is Tuesday, and up here on the table we had Monday. The question says, Becky was asked to compare the distribution of the lengths of time people waited on Monday with the distribution of the lengths of time people waited on Tuesday. She wrote, people had to wait longer on Tuesday than on Monday. Give one reason why Becky might be wrong. So what I think Becky's done here is I think Becky's looked at the longest time and said on Tuesday someone waited 210 minutes and on Monday the longest wait was only 200 minutes. So therefore on Tuesday they waited longer than on Monday. But actually if we look at the median on Monday was 120. So the average wait on Monday was 120. But the median, the average wait on Tuesday was 100. So actually, on average, people waited less time on Tuesday. So I'm going to say the median on Tuesday was lower. On average, people waited less time on Tuesday. There we go. Question number 10. Enlarge triangle A by scale factor 2.5 with centre 0, 1. So an enlargement from this point, we need to make sure that we enlarge the shape. We also need to make sure that we enlarge the gap from the centre to the shape. So first things first, let's have a look. How far is it from the centre to this coordinate here? It's 2 squares across. So I want to take every dimension here and make it 2.5 times bigger. So I'm going to take those 2 squares and times it by 2.5, which is 5. So now the gap to my new shape, I know, is going to be 5. So because the original gap was 2, and again we're going back from the beginning here, we need to make our new gap 5 bigger. So 1, 2, 3, 4, 5. Our new shape is going to have a corner, a vertice there. Now, how far is it to this point here? Well, at the minute, it's 2 across and 4 up. If I times both of those dimensions by 2.5, it's going to be 5 across, and instead of 4 up, 2.5 times 4 is 10. So we're going to go 5 across from the beginning and 10 up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 to here. And with this corner over here, I've gone 4 across and 4 up. If I'm timesing that by 2.5, I now, from here, need to go 10 across and 10 up. Now, I've counted little squares when I've done this, but actually, looking at it, 2 little squares was 1 whole, so you might have done that instead. And there we go. That is now 2.5 times bigger, and it's from that centre. Now, to double check, you can just join these lines up. The coordinates should connect, the corresponding coordinates should connect, and it should look a little bit like that. Before it was 4 tall, it's now 10 little squares tall. So it's 2.5 times bigger in all dimensions, and that is our enlarged shape. Question number 11. ONQ is a sector of a circle with centre O and radius 11. Okay, so that means we know that it's 11 all the way out to here. 11 in that direction, and 11 in that direction. A is the point on ON and B is the point on OQ, such that AOB is an equilateral triangle of side 7. So this is 7, and this is 7. Calculate the area of the shaded region as a percentage of the area of the sector ONQ. Give your answer correct to 1 decimal place. So first things first, because we know that this is an equilateral triangle, all 3 sides are the same, I know that this angle here is 60 degrees. Because if it is equilateral triangle, all the sides are the same, all the angles are the same, 180 divided by 3 is 60. So it'd be 60 degrees in each of those angles. Now we need to calculate the area of the whole thing, and then calculate the area of the triangle and subtract it. And that's going to get us the area of that shape shaded that's left like that. Okay, so let's do the area of the sector is going to be pi r squared times by the number of degrees it is out of 360. And the radius we know is 11. So pi times 11 squared. Pi times the radius squared is going to get you a whole circle, but you only want that slice. That's why you times it by 60 out of 360. So pi times 11 squared times 60 out of 360. And that gets me 121 over 6 pi, and you might just want to leave it like that for now. So 121 over 6 pi. Because I'm going to use it in a minute, I'm just going to keep it like that. Now we're taking away the area of the triangle. The area of a triangle, I don't have the perpendicular height, so I'm going to need to use half AB sine C. And we use half AB sine C when we don't have that base and perpendicular height. So I'm doing half times 7 sine 60. A and B are sides. Capital C is your angle in between the 2 sides. So half times 7 sine 60 is 49 root 3 over 4. And again, I'm not writing it as a decimal yet just because I want to keep it as accurate as I can till the very end. And if I subtract those from each other, so I'm going to now type in my calculator 121 pi over 6 minus 49 root 3 over 4, and that equals 42.137829. But that's not my answer. I need the area of the shaded region as a percentage. So I now need that answer out of the total area, which was this one, 121 over 6 pi. And then because I want it as a percentage, I need to times it by 100. So in my calculator, I'm putting answer divided by, and then I'm going to type in that fraction, so 121 over 6 pi, and then we're timesing that by 100. And that gets us 66.5101, which to one decimal place is going to be 66.5%. Question number 12. Prove algebraically that the sum of the squares of any two consecutive even numbers is always a multiple of 4. So with proof, an even number is written as 2n. An odd number is written as 2n plus 1. And if I want two consecutive even numbers, then I want an even number, and to get to the next even number, we know would be 2 bigger, because when we add 1, we get an odd number. So if I go up 2 from any even number, I will get to the next even number. Now we need to do the sum of the squares. So we need 2n, and we need to square it. And we need 2n add 2, and we need to square it, and sum means to add them. So the sum means to add the squares of any two consecutive even numbers. Now if it says prove algebraically, you are going to get absolutely nothing for doing 4 squared add 6 squared, or 10 squared add 12 squared. You can do as many examples as you like and show that it works. You're not going to get any marks unless you do some algebra. So even number is 2n, the next even number is 2n add 2. If you want an odd number, it's 2n add 1. And then if you wanted the next odd number, it'd be 2n add 3, and so on. So let's expand this out. 2n squared means 2n times 2n. So that's 4n squared. And then 2n add 2, I'm going to square it, which means writing that bracket out twice. And that is 4n squared, add 4n, add 4n, add 4. So altogether, if I add this with this, I've got 8n squared, add 8n, add 4. Now we're trying to show that this is always a multiple of 4, always in the 4 times table. To do that, I'm going to take 4 outside of a bracket. So that's going to be 2n squared, add 2n, add 1. Therefore, always a multiple of 4, because I can take 4 out as a factor. Quite a tricky one, that. Well done if you followed along. Question number 13. A car moves from rest. The graph gives information about the speed of the car after it starts to move. Calculate an estimate of the gradient of the graph at t equals 15. So t equals 15 is here. If I go up to the graph, if I want the gradient at that point, I'm going to want to draw a tangent. So it needs to be as close to the steepness as that point. Do I like that? A little bit steeper, I think. No, I've gone too far the other way. There we go. That seems about right. So I'm trying to match the steepness of the graph at that point. And then what we need to do is make it into a triangle. Now I'm going to try and pick some points that look quite nice, she says. I've not really done myself any favours there. So let's go to here. And let's go to here. And we're going to do the rise divided by the run. That's going to get you the gradient. So the bigger you make that triangle, the easier. And also try and pick points that are quite nice. So I've gone up from 14.5 to 25. So 25 take away 14.5 means I've got a rise of 10.5 in that direction. And the run, the x direction, I've gone from 10 across to 25. So that's gone across by 15. So therefore, if I want the gradient of that graph, I'm going to do the rise divided by the run. 10.5 divided by 15 gives me a gradient of 0.7. Now you might have got a slightly different answer. There'd probably be a range of answers available to that. I'll look up the mark scheme and I'll let you know what the range was in the comments underneath. But there would be a range of answers, but that's how you do it. 0.7 is what I got. Describe what your answer represents. So the steepness of the speed. How much the speed is changing by, that is the acceleration. Then, for part 2 or part B, we've got work out an estimate for the distance the car travels in the first 20 seconds of its journey. Use 4 strips of equal width. So for the distance on a speed time graph, it is the area underneath the graph. So for the first 20 seconds, takes us up to here. Let me get rid of this. The first 20 seconds, we're going to go up to here. And it says do 4 equal strips. So we're going to go 1, 2, 3, 4, and then we need the area of each of those bars. Now, obviously it's not possible for us to exactly work out that area, not without knowing how to integrate. So what we're going to do is make them into triangles and trapeziums. Like that. And work out the area. Now you can work them out as trapeziums, but I know a lot of students like to split them into rectangles and triangles. So I'm just going to do it that way just because I think that that's what most of you would do. And I'll go with the majority here. And then we're just working out the area of all those sections. So for this little triangle here, it's 5 wide and 4 tall. So 5 times 4 divided by 2, because it's a triangle, is 10. For this bit here, I've got 5 times 4, that's 20. And then for the triangle, we're going from 4 up to 12. So 8 times 5 divided by 2 is 20 for that section as well. For this next bit, I've got 5 times 12, which is 60. And then for the triangle at the top, I'm going from 12 up to 16, 17, 18. So from 12 up to 18, so that's 6 tall, 5 wide, 5 times 6 divided by 2 is 15. And then last but not least for this section here, 5 times, what did I just say? 18. 5 times 18, which is 90 for that rectangular bit. And then for the triangle, you're going from 18 up to 20, so that's 2 tall, 5 wide, 5 times 2 divided by 2, because it's a triangle, is just 5. Adding all of that together, so I've got 10, add 40 for the next strip, add 75 for the next strip, add 95 for the last strip, and that is 220. So we would say that the car has travelled 220 metres, and all my working's up there on the graph, so that's okay. You could copy it down if you really wanted to, but the examiner would see that, so that's fine. Question number 14. Solving this equation, give your answers to 3 significant figures. So with this algebraic fraction, what we're going to want to do is make the denominators the same to be able to add them. And we're going to do this multiplied by this multiplied by this, and then the denominators multiplied together. So 1 lot of x minus 1, add 3 lots of 2x minus 1, all over 2x minus 1 times x minus 1. And that equals 1 still. So all we've done there is make it a single fraction and make a common denominator of 2x minus 1 times x minus 1. I'm then going to multiply both sides by that denominator. And that's going to make it not a fraction anymore and bring it up onto this side. So 2x minus 1 times x minus 1. So now I've got, and I'm going to expand this out at the same time. 1x minus 1 is x minus 1. Add 6x minus 3 equals, now because this is a 1, I'm okay to just write this, expand this out as it is. If it was a 2, I'd probably expand the brackets out and then double everything afterwards, but because we're just timesing it by 1, it's okay to just write 2x squared minus 2x minus x, add 1. Simplifying that down, I've got 7x minus 4 on this side, equals 2x squared minus 3x, add 1 on this side. And I'm going to take 7x away from both sides. And I'm going to add 4 to both sides. I want it to equal 0 because it's a quadratic. So 0 equals 2x squared minus 10x, add 5. Now, it says give your answers to 3 significant figures, which is a massive clue that I don't think this is going to factorise. So we're going to use our quadratic formula here. And we're going to do minus b plus or minus the square root of b squared minus 4ac all over 2a. You do get that in the front of the exam. So that's going to be minus minus 10. Now there's no point putting minus minus, we can just put 10. Plus or minus the square root of. It should be minus 10 squared. If you're going to put minus 10, make sure you put it in brackets, because otherwise your calculator will say it's minus 100 when it's actually 100. Minus 4 times 2 times 5, all over 2 times 2. So this is your A, the number in front of x squared. This is your B, the number in front of x. And this is your C. So I've just put those values in. It looks like that. Typing that in my calculator. The first time you type it in, you're going to want to use the plus, and the second time use the minus, or the other way around, but one at a time. The square root of 100 minus 4 times 2 times 5, all over 2 times 2. And that is 4. Oh, I've kind of written on the answer line here, haven't I? Get out the way. 4.436. What are we rounding to? 3 significant figures. So 4.44. 4.43649. And then going back and using the minus, that's going to be 0.563508. So to 3 significant figures, 0.564. There we go. Question number 15. Here's a triangle ABC. Find the length of BC. So if we're given a non-right angled triangle and we're asked to find the sides or the angle, then we want to use either sine or cosine rule. We already had sine rule come up in one of the earlier exams. We haven't had cosine rule yet, which is why I've put this one in here. Now this is the perfect setup for cosine rule. You've got 2 sides and the angle in between, and you want the opposite side. So the cosine rule is given to you. A squared equals B squared plus C squared minus 2BC cos capital A. So little b and little c, they're the sides, and then capital A is the angle. So 8 squared, add 11 squared, minus 2 times 8 times 11 cos 72. Type that in your calculator, but remember that that is A squared, so we are going to have to square root that to get our final answer. 8 squared, add 11 squared, minus 2 times 8 times 11 cos 72. And then square root that answer, so let's do the square root of all of that, is 11.4286, so to 3 significant figures, 11.4. Find the area of triangle ABC, give your answer to correct to 3 significant figures. So I've included this in a couple of questions. And remember, for area, we're doing half AB sine C. So this again is the perfect setup for that. You've got 2 sides, 11 and 8, and the angle in between, 72 degrees. So it's going to be half times 11 times 8 times sine 72. So typing that in my calculator, I'm just going to use 0.5 times 11 times 8 times sine 72. And that is 41.846, so to 3 significant figures, 41.8 centimetres squared. Question number 16. The density of ethanol is 1.09 grams per centimetres cubed, and the density of propylene is 0.97 grams per centimetre cubed. 60 litres of ethanol are mixed with 128 litres of propylene to make 188 litres of antifreeze. Work out the density of the antifreeze. So let's start by drawing our triangle: density, mass, volume. Now, with these triangles, you always want your units to match up. So our density is in grams per centimetres cubed. We want the volume to be in centimetres cubed, and we want the mass to be in grams so that it all matches. However, at the minute, we've got our volume in litres. Now, it's good to know that 1 centimetre cubed is a milliliter. So if we can get this in millilitres, then it will be the same as in centimetres cubed. So 60 litres, 1 litre, is 1,000 millilitres. So this is the same as 60,000 millilitres, which is 60,000 centimetres cubed. To lay out this question, I like to do 1 bucket for ethanol, add the bucket for propylene, and I did one of these on my last predicted paper as well, I think, because I like these questions and I kind of hope they come up. And that makes the antifreeze. And for each, we're going to do density, mass, volume, density, mass, volume, and density, mass, volume. So our density of ethanol is 1.09 and our density of propylene is 0.97. 60 litres, we've said that's 60,000 millilitres or 60,000 centimetres cubed, and then the propylene we know is going to be 128,000, same method, centimetres cubed, to make 188,000 millilitres or centimetres cubed of antifreeze. Work out the density of the antifreeze. So we're going to start by getting the mass of ethanol, then get the mass of propylene, and that will allow us to add them together and get the mass of the antifreeze. You can add together volumes, you can add together masses, but you can't add together densities because it's a compound measure. So to get the mass, if you cover up M in your formula triangle, you're doing density multiplied by volume. So 1.09 times 60,000 is 65,400. And let's just type our working up there, or write our working up there, sorry, times 60,000. And then for the next one, we're doing 0.97 times 128,000, and that is 124,160 grams. And then we can add those together. So 124,160 add 65,400 is 189,560 grams. And that's the mass of the antifreeze. Now to work out the density of the antifreeze, again we're looking back at this triangle up here, and density is mass divided by volume. So 189,560 divided by 188,000 is going to equal our density. So divide that by 188,000 and that gets us 1.00829. We've got to do it to 2 decimal places, so that's going to be 1.01 as your final answer. Now it is worth saying that if you hadn't converted into centimetres cubed, it would still have worked. But I'm going to encourage you always to make your units match, always think about these things properly and make sure your units are, aligned. Question number 17. The number of animals in a population at the start of the year T is PT. The number of animals at the start of year 1 is 400. Given that PT add 1 is 1.01 PT, work out the number of animals at the start of the year. So this is really just checking your understanding of notation. All this means is to get to the next year, you're going to take 1.01 and multiply it by this year. So P with a little t is the year you're on now, and PT plus 1 just means next year. So this looks really complicated, but all it means is this. If you want next year, you just need to times the current year by 1.01. So therefore, year 1, we know there are 400 animals in the population. For year 2, we're going to do 1.01 times by that 400, and that is 404. And then for year 3, we're going to take that last value, 404, and times it by 1.01, and that is 408.04, so I'm just going to round it to be 408. There we go, for 2 marks. Question number 18, show that m add 4, 2m add minus 5 and 3m add 1 can be written in the form this. So we're expanding 3 brackets. Don't let this bit confuse you. It just means it's going to be something cubed, something squared, something, and then a number on the end. Or you might have any of those numbers being 0, but anyway, it's in that format, your answer. So we're going to do this by multiplying the first 2 brackets together. So m add 4 multiplied by 2m minus 5, and that's 2m squared minus 5m add 8m minus 20, which is 2m squared add 3m minus 20, and then we're going to multiply that by the third bracket, bring that down, and we're going to do 2m squared times 3m and 2m squared times 1. So first thing we're dealing with is the first term here. So 2m squared times 3m, that's 6m cubed, and 2m squared times 1 is just 2m squared. And now we're moving over to this second term, and we're going to do 3m times 3m and 3m times 1. So that's going to be 9m squared add 3m, and then we're moving over to the third term, which is minus 20. So minus 20 times 3m is minus 60m, and minus 20 times 1 is minus 20. We can now just collect together any like terms. We've got just 6m cubed on its own, and then 2m squared and 9m squared makes 11m squared. 3m minus 60m is minus 57m, and then minus 20, and that is your final answer. So we're just looking at this and saying A is 6, B is 11, C is minus 57, and D is minus 20. Not relevant, but you just need to know that when they ask you this, it's not to scare you, it's just to say your answer's going to look a little bit like that. Question number 19. The diagram shows a sketch of part of the curve with equation y equals cos x. P is a minimum point on the curve. Write down the coordinates of P. So we should know that both sine and cosine go up to 1 and down to -1, usually. They also repeat every 360 degrees. So everything interesting that happens can be split into quarters of 360. So with sine, not that it's relevant for this question, but I'm just doing it as well. So sine starts at 0, goes up to 1, 0 again at 180, down to -1, and then 0 again at 360. And at 90 degrees, that's when it's at the top, and at 270, that's when it's at the bottom. For cos of x, it starts at 1, goes down to -1 and back up, and that's what we've got here. So I know that this is going to be 1, and I know that this is -1, and we know that that repeat happens every 360 degrees. So this point here, we know it's down at -1, and we also know that because it's halfway through that repeated section, that's 180 degrees. So the coordinate they're looking for here, remember you're going along the corridor up the stairs, so 180 in the x direction and -1 in the y direction. Question number 20. Sketch the graph of y equals 2x squared minus 8x minus 5, showing the coordinates of the turning point and the exact coordinates of any intercepts with the coordinate axes. So for this, we're going to complete the square. If we need the turning point, we're going to need to complete the square. Now, we normally complete the square when a, the number in front of x squared, is just 1. So if it's 2, we're going to need to factorise it out. So I'm going to start by taking that 2 outside of a bracket, and that would leave me with x squared minus 4x. Now, I don't like to take the end term into that bracket, so I'm just going to leave the -5 outside there. Now, we're going to complete the square on this part, so that's going to be 2x minus 2 squared. Remember, for completing the square, you halve this number and then take away this number squared. So -4, and then we've still got the -5 there, and then bring that 2 back in. So that's 2 lots of x minus 2 squared, minus 8, because we're doing 2 lots of the -4, minus 5. So that is 2 lots of x minus 2 squared, minus 13. So now we can see that our turning point is whatever makes this bracket equal 0, whatever value of x makes that bracket equal 0, and then whatever constant term we get on its own here. So the turning point is 2 minus 13. So that's the first thing that we needed to know. The second thing we need to know is where it crosses the axes. So because the turning point is 2 minus 13, I know that it's going to turn somewhere down here on this side. I'm going to put 2 minus 13 there. I also know that it's going to cross the y-axis at -5. So a little bit like y equals mx plus c, the number on the end, that's where it's going to cross the y-axis. So let's put that there and say it's going to cross there at -5. I now know that this quadratic is probably, I've drawn that absolutely terribly, but hopefully you can forgive me. It looks a little bit like that. And the last thing they want is the intercepts with the x-axis as well, because it's any intercepts with the coordinate axes. We've done the y-intercept, we now need the x-intercept, which we're going to get by doing the roots. Now you've got a couple of choices here. Because we've already completed the square, we can now make this equal 0 and solve this. So to solve this, we would add 13 to both sides first. So 2 lots of x minus 2 squared equals 13. Then divide by 2. So x minus 2 squared equals 13 over 2, or 6.5. Then you're going to square root. So x minus 2 equals the positive or negative square root of 13 over 2. And then add 2. And we can just put that at the front. So 2 plus or minus the square root of 13 over 2. Now you can just type that in your calculator. However, if that makes no sense, so from there, if you're finding that really confusing and you're not quite sure what I did there, then absolutely just use the quadratic formula. Just look at that equation, use your quadratic formula just like we did earlier on, with 2 being a, b being -8 and c being -5. You should get exactly the same answer. So I'm just going to pop that in my calculator. 2 plus root 13 over 2. And that is 4.5495. Oh, hang on a minute. Ignore me, because it says the exact values. The exact values. And if it's exact, we're going to leave it in surd form. So typing this in my calculator. So this coordinate here, when we've used the positive, we've got 4 plus root 26 over 2. And this coordinate here is going back and using the negative 4 minus, oh, let's go this way, 4 minus root 26 over 2. Now, I'm going to be proper about this, and I'm going to say that this coordinate is 0 minus 5, and I'm going to say that this coordinate is this 0, and this coordinate is this 0. And we've got the turning point. So there we go. We've got all intercepts with the axes. We've also got the turning point, and that is 5 marks. Question number 21. Triangle A is transformed by the combined transformation of a rotation 180 degrees around the point -2. So if I'm rotating it around the point -2, 0, it's going to end up down here like this. That would be a rotation 180 degrees. And then we're doing a translation by the vector -3, 2, which means 3 left and then 2 up. So then from here, it's going to go 1, 2, 3, 2 up, and it's going to end up here. Now there is one point that hasn't moved under that transformation. There's one point that hasn't moved, and it's this point here. This is the only coordinate that has not changed. After I've done all that, it's still in exactly the same point. So that point has not moved, and we call that the invariant point. So there is one coordinate that has not changed after that transformation, it's that point there, so we're going to put -3.5, 1. Very tricky, but actually quite nice when you know how, so hence why I've put it on there. Question number 22. The diagram shows the positions of 3 towns, Acton, Barston and Chorlton. Barston is 8 kilometres from Acton on a bearing of 37 degrees. Chorlton is 9 kilometres from Barston on a bearing of 150 degrees. Find the bearing of Chorlton from Acton. So I'm going to draw a line here because the bearing that I actually want is always bearing start north and go round until you're facing the direction you want. So the bearing of Chorlton from Acton means you're stood at Acton looking at Chorlton. How many degrees round is that? So essentially we need this angle here, and then we can add it onto 37. Now to be able to work out that angle there, we're looking at that triangle ABC. Let's fill in everything that we know so far. So I'm going to also say that I know this number of degrees up here because we've got co-interior angles here, because both lines are parallel. This angle here is 180 minus 37, which is 143, which means we know that this angle here inside the triangle is 360 minus 143 minus 150. And that gives me an angle of 67 degrees. So that's that one there. What else can we now get? Well, we now have 2 sides and the angle in between. We could also get this one is 30 degrees, but I don't think that's going to help us very much. So no, all good. Now let's have a look. We can get this side, and to get that side, we can use the cosine rule. And we're looking at the angle here and the 2 sides, 8 and 9, and using the cosine rule, that's going to get us x. So a squared equals b squared plus c squared minus 2bc cos a. So 8 squared plus 9 squared minus 2 times 8 times 9 cos 67. We're then just going to type that in our calculator and square root our answer. So that is 88.7347, but obviously we're going to square root that answer to get a. And so a is 9.419910695. There we go. So that's the length of this one here, 9.4199106. Great. Now what we can do is use the sine rule and use that pair that we've just found to then get us this pair, and that will get us the angle. We want an angle, so we're going to put the angles on top of the sine rule. So sine A over A equals sine B over B. So sine 67 over 9.4199, I'm just going to use the answer button in my calculator, equals sine B, which is the angle that we're looking for, this one here, over 9. So to work this out, I'm just going to times both sides by 9 to get rid of that. So in my calculator, I'm typing sine 67 over answer, just to put that last answer I got in, times by 9 equals 0.87947, but remember that's sine B. So then to get my answer, my angle of B, I just need to do sine to the -1 of that answer, so shift sine of that answer, and that is 61.578. That's not our final answer though, remember that was just this bit, so we need to add on 37, and that is 98.57. We're giving our answer to one decimal place, so 98.6. It is a bearing and it is under 100, so I'm going to put 098.6 degrees. There we go. Find the bearing of Chorlton from Acton. That is my final answer. I hope you've enjoyed the paper. I made it quite difficult intentionally. I hope that will prepare you well. Good luck with your final exam, and I hope you found this helpful. Let me know in the comments how it goes for you.